All right, welcome to video 3 of my AP Calculus Chapter 3.2 videos. This video, guys, I want to talk about using a calculator, and what I am about to tell you applies to the TI 8384 line of calculators. I'm going to assume that most calculators do the exact same thing. I don't actually know. TI 8384 is somewhat prevalent in high school education. And so we do a lot. And the question is, what if I want to find a numerical derivative? I want to know what the value of the derivative. I'm not interested in the algebra. I'm not interested in an equation. I just want to know what it's equal to at a particular point. What can I do in my calculator? So there is a function called ender, sometimes nderiv. And of course, if you have math print in your calculator, it will look like this. And you just fill in what you need. And the way it works is by doing a numerical approximation. It doesn't actually take a limit, calculate the function, or have all the functions stored in the calculator. Which, of course, since there's an infinite number of functions, would be awkward. But what it does is it uses an approximation. So we've always said f prime of the derivative at a is the limit as x approaches a of f of a plus h. Wow, I just said that completely wrong. The limit as h approaches 0. Sorry. But for very small values of h, we can approximate this as f prime of a is approximately f of a plus h minus f of a divided by h. Because for very small values of h, well, that's sort of similar to or close to that limit as h approaches 0. We don't have to actually go to 0. We can go to 0.0001 and see, well, it seems pretty close. So we could just tell our calculator to do that. Just pick some small value of h and tell the calculator use 0.001. And say, oh, do that calculation. Well, what happens when a function is coming down and then coming up? What if I go in one direction, it's higher? Obviously, my approximation is going to be off because it's above. So if I took the average of 2 points, if my function is just going up, it doesn't matter. I take the average of 2 points, they're both the same. But if my function changes direction, all of a sudden the average gives me a better value of what's actually happening there. So what I do is I take a point above, I add it to a point below, and I divide the whole thing by 2. So what have I got now? Well, what I end up with by doing a little fiddling is I've got that I take the value above and I subtract the value below. Whoops. Subtract the value below, which is a minus. And I divide that by 2h for small values of h. And we're actually then just going to say h equals 0.001, which means that what my calculator is going to do to find the numerical derivative of some function at an x value of a, it is going to say, well, I'm going to take the function at a plus 0.001. I'm going to take the difference between that and the function at a minus 0.001, and I'm going to divide it by 0.002, and that is going to give me a, turns out, fairly accurate approximation of the value of the derivative of my function at x equals a. I'm going to pause and stop this video actually, and I'll do an example because I've only got 5-minute videos. And I'll go ahead and do an example and show you how close it can actually be in just a minute. Meanwhile, you might take a look at your calculator and look at the math menu, and I believe in the TI-8384 you'll find that option 8 is this numerical derivative. So take a look at that and see what pops up in your calculator, and we'll be right back with an example.